Okay, anybody have a question on the quiz? Now, the back side of this quiz is hugely important. Do not put this quiz in a place where you'll never find it again, because the other side of it is very, very important. These are our simplification problems that we're going to keep practicing. Ron?
I have an announcement.
Yes.
Due to our phenomenal performance this Sunday, my co-ed team for basketball will be playing Fest this Friday.
Okay.
We will be supporting our team.
I was there last night to watch part of it.
I will make t-shirts, tank tops, and pom-poms. Put it over the top.
Tomorrow is Math League. Please don't forget, I forgot to take my sign up, but tomorrow's Math League. Yes. Okay, so let's look at problem number 4. There is a certain amount of work that needs to be shown. And the reason that there is a certain amount of work that needs to be shown is because the answer is either 0, 1, or 2, right? So you could guess. You have a 33% chance of guessing correctly. I don't get points for guessing. We need to show our work. So here's the situation. All right, so you look at this and you see a pair of information here. Bryce, we have a pair, so this is going to be a law of signs problem. So sine 48 over 10 equals sine h over 11. Now this is what puts me in alert mode. Anytime I do my law of signs and my variable is an angle, I know I've got potentially more than one answer, or maybe no answers. So let's cross multiply. So we have 11 sine 48 equal to 10 sine h. So the sine of h will equal 11 sine 48 divided by 10. Now, is everybody okay to that point? So then I get my calculator out, and I'm going to type in that fraction, and I'm going to get a decimal. And then what am I going to have to do to that decimal? I'm going to second sign, second answer that decimal, right? And I get 54.83. As soon as I get that, I step over to the side and I redraw my triangle exactly from the given, just like the given. And then I say to myself, okay, one answer is 54.83. The other answer, if there is another answer, the other answer will always be 180 minus that. So that would be 125.17. And then I look at this second triangle and say, could I be 48 and 125? And the answer is yes. The triangle would look weird, but it's okay because it's less than 180. So there are two triangles possible. The quiz was worth 12. If I put something else on there, it means I didn't see enough work to make it possible. Where's the 125? The other answer. Yeah. So this is the work. This is the work you need to show. I should see on your paper a 54 and a 125. Okay? Otherwise, it looks to me like you guessed or somebody at your table gave you the answer. You have to show, that's the work you show. Okay? Anybody else have a question about the quiz? Now, it is imperative that you hang on to this quiz, okay? Because of what's on the back of it. So the rest of it we're good on? All right, I want to do a quick recap of what we have learned so far. So I'm going to put two triangles up here. Brooke, what's your middle name? Katie Baumgartner, what's your middle name?
Abigail. It's spelled wrong on my birth certificate.
Okay. Thank you for that information. Okay, here's our first problem. And the directions say find side B. Find side B. That's the question. Now remember, groupies, when you are finding parts of triangles, you have three options. SOHCAHTOA, law of sines, law of cosines. SOHCAHTOA will only be used if the triangle is right. I do not see a 90-degree angle there, so that's out. So then you're going to decide if you're going to use the law of sines or cosines. What is the key? How do we know which one we should be using? Jack?
Let's say you have a big S and little s, you do a sine.
Yep.
Because you have both of them. And
Yep,
don't
you have to
use
have the
this.
set. Now, in this case, at first glance, it looks like I don't, but I really do have a set of information. Do you see why? If this is 82 and this is 53, what's this one going to be? That's a no-brainer. We should be able to figure that out. 40 what? 5, I think.
45.
So then I can say sine 45 over 10 equals sine 53 over b. I can cross multiply. And divide. So b will end up equaling 10 sine 53 divided by sine 45. So I can type that into my calculator, and I will have angle, or excuse me, side B. I got 11.29. Anybody have a question about the law of sines? All right, then let's look at this triangle. I want to do the same thing I just did. I want to find a side. This time I want to find side K. Now take a look at that triangle. Can I do the law of sines? It's going to have to be the law of cosines, right? So I will say K squared equals what? 12 squared, good. Plus 13 squared, good. Minus 2 times 12 times 13 times cosine 53.
53.
I can type this in just like it is. There's no variables in there. So I can type it in just like it is. 12 squared plus 13 squared minus 2 times 12 times 13 times cosine 53 equals. And then what do I have to remember to do with that number?
Square root.
Square root it. that one works out to be 11.19. Now, does anybody have a question about law sines, law cosines? Because today we're going to add the final piece to this little unit. Today we're going to talk about finding the area of a triangle. So would you get your note sheets out, Caitlin? Okay. Now let's look at our note sheets on page, back of page 42. On the back of page 42, we're going to look at our note sheet. These directions say find the area. We are going to start with problem B. And it says find the area. Believe it or not, this is incredibly easy. You already know how to find the area of a triangle, don't you? 1/2 base times height. What's wrong with just doing 1/2 base times height with this problem? You don't have the height. Now we could find the height. It would take a little bit of effort, but we could do it. Luckily, some really smart dudes did all that work for us and put it in a simple little formula that we are going to use so that we don't have to find the height every time we want to do this. Our new area formula that is so handy and we use it all the time. Our new area formula is 1/2 times side times side times sine of included angle. Now, you will hear me refer to this as 1/2 side sine. What do I mean by included angle? If I have two sides of the triangle, side times side, here are my two sides, what do I mean by included angle?
58.
The one that's in between them, right?
Yes.
So if you had this situation, that would not work.
No.
Do you see that? That wouldn't work. If these are the two sides you have, this is the angle you need, the one that's between the two sides. So if we had a situation where we had this, we'd be good. 1/2 side sine. Okay, which is exactly what we have here. So our area, kids, I mean, there's no work to show except to write down the formula. The area will be 1/2 10 times 12 times the sine of 58. That's it. You've got your area. No, nothing to do except type it in. 1/2 times 10 times 12 times sine 58. And that area is 50.88. Does anybody question, I know you've never seen that formula before, but once you get that formula learned, are you good with this? Look at problem number C. What would you say the area of that triangle is going to be? Look at C. What is its area going to be? 1/2 16 times 15 times sine 84. Bingo, that's all there is to it. Type it in. 1/2 16 times 15 times sine 84. I got 119.34.
That was my guess. That's exactly my guess.
Are you okay with that?
Yes.
Now, take a look at problem A. What's different about problem A? There's no angle. So here are your choices. You can find the angle using the law of cosines, or you can use another nifty little area formula called Heron's formula. And Heron's formula looks like this. Now, I know when you look at that formula, this is called Heron's formula. And I know when you look at this, I used to have such good handwriting, I don't know what
You still
happened.
do, in my opinion.
Hero was actually Heron of Alexandria. He was one of those famous mathematician types called Hero's formula. And it looks really complicated, but it is super simple to use. Hero's formula is used when we have all three sides. In the real world, it's actually quite common to have all three sides. For example, your house, I don't know what kind of lot your house sits on, but it's possible that your house could, or somebody's house could sit on a triangular lot. And if you wanted to know the area of the lot, you could easily measure these three sides. And then Hero's formula would find the area. Here's how it works. In the formula, the S stands for semi-perimeter. Does anybody want to take a guess what semi-perimeter means? Half the perimeter. It means half the perimeter. So for us, what's our perimeter? This is question A. What's the perimeter? 38. So the semi-perimeter would be 19. So our area is going to be a square root. Hero's formula is a square root. And we're going to start with 19. What do you think the A, B, and C stand for in the formula? Think about triangles now. The sides, those are the sides. So we're going to take 19 minus side A. So 19 minus side A would be 19 minus 12. Then we're going to take 19 minus side B and 19 minus side C. Now, I went ahead and showed my work. The next time you do this, you'll probably do that in your head and just write 19 times 7 times 3 times 9. Now we'll multiply 19 times 7 times 3 times 9 and get 3591. And then we'll take the square root of that, and our area is 59.92. Now kids always say to me, Mrs. Ford, how do I know which area formula to use? And the answer is it really doesn't matter. You're always eventually going to get the area. But if you have been given all three sides, if that's the information you have, I would definitely use Hero's. If you have been given two sides and the included angle, I would definitely use the top one. All right, let's try D. Question D. What have we been given in question D? We have been given all three sides. So which way would be fastest to find the area? Hero's. So the area will be a big radical. Now what's the first thing I need to do if I'm going to use Hero's formula? I need to find the perimeter and cut it in half. So the perimeter here would be what? 43? Is that right? So if the perimeter is 43, then the semi-perimeter will be 21 and a half. Now don't panic, I know it's a decimal, but you know what, we're gonna do it on our calculator, so it really doesn't matter. So we start with 21 and a half. Then we take 21 and a half and subtract each of these, right? So 21 and a half minus 17. Now I'm old, I can do that in my head. If you can't, put it in your calculator. 21 and a half minus 11. $21 and a half minus 15. Then I'll type it all together and take the square root. Please don't take the square root until you've typed them all together, multiplied them all together. So we have the square root of 6603.1875, which is 81.26.
You said 6603?
I think so. The answer should be 81.26. That's not too bad, is it? Let's look at E now, because E could ruffle our feathers a little bit.
So we have a test this Friday.
Yes.
If we have one of us on Friday, one of the shortest schedule.
What if this is next Friday?
Okay, we'll worry about that another time. Right now, we're focused on, we have to find the area of this triangle. Tell me what's wrong with it.
There's no other side.
Well, I don't have all three sides. So there is no way I'm doing Hero's formula, because I don't have all three sides.
Not a side.
What's wrong with the other method?
Two angles.
Yeah, and I really need two sides and the angle in between them. So could I find this angle? What would that angle be? 69? How did we get 69? 180 minus these two added together, right? Okay. Boy, I really need to know like this side right here.
Do that one thing. Oh,
Do one thing.
the one law sign.
The law sign. I have a set. I need to know something else about my triangle. Law signs or law cosines are my options. Since I have a set, I'll do my law signs. So sine 69 over 16 equals sine 49 over b. Now some of you are not completely awake and alert this morning. So you're sitting there thinking, what is she doing? Why is she doing this? My job is to find area. Right now, you have two strategies for area. 1/2 side sine of included angle and Hero's formula. Hero's formula is out because you need all three sides and you only have one. The other formula we're close to if we had this side. Because if we had that side, could we do 1/2 16 times this times sine 62?
Yeah.
So we need to find that side in order to find the area.
12.93.
So here we go. I'm cross multiplying. Was there a hand up, Jack?
Does it matter if you, what if you use like, A instead of B? Would that matter?
No, it would not. The only thing that's going to change, Jack, is if you found side A then you would do, your area would be 1/2 16A sine 49. Mine's gonna be 1/2 16B sine 62.
Okay,
But the answer, both of us are gonna get the same answer.
okay.
Okay, so here we go. Here's my side B. I've been talking a lot, so I hope I didn't mess this up. I got 12.93.
Yeah.
Now that is not the answer to the question, kids. That's not what I'm shooting for. My answer is going to be the area, which is 1/2 16 times 12.93 times sine 62. That's my area. 1/2 side, side, sine of included angle. In a perfect world, you get exactly what you need in the problem. But if you don't, sometimes you have to do this background work. Did you get 91.33 as your area?
I just did, yes.
Okay, now, I need you to bravely turn the page over.
Yeah.
Are these word problems I see?
Yep.
Oh my gosh, how's it going?
All right, so here we go. We're going to see if we can figure out how to do problem 1. All right, so I need everybody paying attention. Will Alec, everybody's paying attention. And we're going to give this a shot. So let me just draw a picture of the scenario. I have a circle. Inscribed in the circle is a hexagon. How many sides does a hexagon have? 6. I'm going to make 6 marks evenly spaced around my circle, and I'm going to connect those marks. So here is my hexagon inscribed in a circle. So I drew my circle, spaced out 6 hash marks evenly around, connected the hash marks. That made my hexagon. Now, the radius of the circle, so this right here would be 22. So would this, this, and this. All of those are 22s. Now, how many of those triangles are in that picture? 6. And because the hexagon is regular, do you remember what regular means? All the sides and angles are congruent. So that means all of these triangles are congruent. These are all the same size triangles. And there's 6 of them. How big would this angle be then right here? Now keep in mind, this is a revolution right here. And there's 6 of them. 360 divided by 6, so this is a 60-degree angle. This is a 60, 60, 60, 60, 60. Kids, they got to add up to 360.
Could you syrup that too?
I can because the triangle is equilateral. I know that this, I would never do that if it weren't a hexagon, and I'm not going to do it now because I want to show you how easy it is to do it without that. Take a look at the information that we have about this triangle right here. We know these 2 sides are 22, and we know that angle is 60. What is the area of the triangle? This triangle right here, what is its area, Tim? How did you get that? Exactly. So he typed into his calculator, the area of the triangle is 1/2 side, sine of included angle. So he got $209, did you say, Tim?
Yeah.
209.58. Now, if you put that down as the answer to the question, you're going to get partial credit. This is the area of the triangle.
Thinks he does.
We wanted the area of the whole hexagon. So what would we have to do? Multiply by 6. So the area of the hexagon will be that number times 6. I got 1257.48.
Yeah, 47.
And that would be square feet. Let's not be worried about why we get out early today. Let's be worried about knowing how to find the area of regular polygons. Okay? Number 4. Skip down to number 4. All right, now what have we got? See if you can do this. We have a regular pentagon inscribed in a circle. So there's my circle. What does pentagon mean? 5 sides. So I'm going to draw 5 hash marks evenly spaced around my circle, and I'm going to connect the dots. That's my pentagon. That's my regular pentagon. Now I know that the radius of the pentagon for all of these things are 28. I really, really, really need this angle.
72.
Some of you have already calculated that angle 72. How do I know? You are exactly right. How do I know that angle 72? There are 5 of them making up a circle. 360 divided by 5. That's a 72-degree angle. Now tell me what the area of that triangle is. What? Well, tell me how you got it. 1/2 times.
Base.
No.
Height.
No.
Wait, no.
1/2 side times side times sine of included angle. So 0.5 times 28 times 28 times sine 72. Whoa, is that 372.81?
Yep.
Now that's the area of the triangle. To get the area of the pentagon, we have to take that number and do what with it?
64.
Times it by 5, because a pentagon has 5 triangles. 1864.05 square inches. Okay? Now, what was the strategy in both of these problems? We didn't really find the area of the hexagon or the pentagon. What did we do first? Split it up into triangles. So when we have some kind of shape, we're gonna split it up into triangles and find the area of the triangles, and then use that to find the area of the actual shape.
Yeah.
So when I see question number 2, and it says I have a parallelogram, I am not going to find the area of the parallelogram. I'm going to find the area of the triangles, and that will give me the area of the parallelogram. So we're told the sides are 14 and 16, and the smaller angle is 48. Can you find the area of this triangle?
Yes.
What's the relationship between these two triangles? They're the same?
They're exact.
So if you find the area of this triangle, it'll be the same as this one?
Yes.
So you'll either double this or add these together, whatever, and you'll get your answer, right?
Yes.
Easy, easy, easy. Split into triangles every time. Okay. All right, that's it for the day. Tonight you have a homework assignment. It is in your book. Tomorrow we will start reviewing for our test on Friday. So we've learned everything now. Just a matter now of regrouping.
Friday.